In this video, we are going to see the method of designing a column with biaxial bending. This is also a simple procedure. Here, we are going to do the process 2 times with respect to x-axis and y-axis. After designing these things, we are going to compare this based on certain chart. Then we are going to finalize as per the guidance given in the video. Corner column in any building. Okay. So what is the given? That is within this square are the given items. Axial load of the column is this much. Moment in x direction is this much. Moment in y direction is this much. Consider the column as a short column. This is the thing we have given. Okay. Now considering the x direction, that is x direction means the column width is higher. Okay. Name of the column, the 5A. In my drawing, this has been given as 5A, the drawing. Axial load 580, that is here, it is here. Okay. Then M20 concrete we are assuming, Fe 500 we are assuming. The characteristic strength of the concrete M20 is 20 Newton per mm square. For Fe 51, Fy rate is this much. We are assuming the column width as 230 meter and depth is 450 meter. And D dash means the cover to reinforcement. We are considering this as 35 mm. The cover to reinforcement is 35 mm we have given here. These are assumed. D effective depth is 450 minus the width of the column minus 35 equal to this much. Next is column moment in x direction 40.8. 40.4 we have already assumed that we have taken, that is the given item. Factored axial load means 380 point something is the axial load into 1.5 is this value. Then column moment factored, this is nothing but the same thing. .4 is the axial load moment into 1.5 is this much. D dash by D, the 35 mm by 450 is D dash by D and value is 0.08. PU by FCK BD. PU by FCK BD is the formula. PU means the factored axial load. 571.32 divided by FCK is 20, B is 230, depth is 450. This value on calculation result I have put it here. Then MU by FCK, the similar type of calculation. Maximum bending moment is factored bending moment is 60.6 into by FCK into B230 into 450 into 450 square. Its value is here, it is given. Okay. Then chart number 48. The data which has been given in red is to be used for selecting something in a chart. This is the book we are going to use for finding the chart. The design aids for reinforced concrete to IS 456 1978. This is the book. Means there are a lot of charts have been given to make the calculation so easy. Now in this first we are going to enter into compression member. Compression member is the column. This is chart number 48, compression member with the bending rectangular. Normally we are going to design this column considering that it is having a uniaxial bending moment in xx direction. Then we will go to biaxial bending. This is the chart for fe 500 and d dash by d equal to 0.1. D dash by d in our section is this much. D dash by d is this much is the d dash by d value. For this we are going to use this d dash by d value is 0.1. This is the nearest value, so we are going to use this fi 500. Okay, then here u by fck equal to 0.28, mu by fck is 0.07, this is 7, 0.28, another value is 0.288. So interpolating this, we are coming here, the factor is 0.02. So this is exactly 0.025. If we arrive it correctly, 0.025, we should type it in the yellow line. Then percentage of steel equal to, this value is P by FCK is this much. FCK value is 20. By putting this as 20, then P value comes as 0.5. This is percentage. So the reinforcement, what is the reinforcement in it? Into 450 depth into 0.5% is this value. Okay. Next, for assuming this much is 517.5 square mm. For calculating for this calculation, we need this statement. That is, 12 mm diameter area of cross section is 113 mm square, 16 is 201 mm square, 20 is 314 mm square. This is the normal tabulation. We can make it by calculating the square mm cross sectional area of each rod. So from this we can choose this. From this we can find that this is very less square mm. So but for being a column, it should have at least 8 rods and not less than 12 mm is required. So but this is, we are designing this only as a uniaxial bending, but we should, this reinforcement should be given little higher for resisting the bending moment in another direction also. So we are assuming this as 8 rods of 16 mm. So the area of cross section comes as this. How much? That is 201 into 8 numbers. This is called, this comes as this much. Then column another, now we have decided that 230 mm width and 450 mm depth with this 8 number of 16 mm diameter rod as the main rod for the column. We are assuming now. Now only we are going to the biaxial bending design. The column name, working axial load, we have already assumed this one. These things are already, we have already assumed the same column. These are M20 concrete steel Fe 500. The characteristic strength 20. The Fy yield strength of steel. Then breadth of concrete we have already assumed as 230, 450 depth. Cover to reinforcement this much. So D effective depth is this much. The diameter of rod we have already assumed. The area of cross section is this much. P equal to the percentage of this. Now the percentage is means what? 1607.68 divided by 230 into 450 is this percentage. That is percentage ratio. That the percentage in that was ratio. Now this we multiplied by 100 is percentage. Okay. Now P by FCK. P by FCK. We already be in previous as done in the previous uh, screenshot. This the value is 0.07. Then factored axial load, we already assumed this as factored axial load. That is axial load into 1.5, it is a factor. Maximum factored column moment, that we are assuming it as mx1 for the reinforcement we have provided. D dash by D is 0.07, we have already assumed. PU by FCK is this much. PU by FCK BD, as similarly we have worked out in the previous session. Using the chart number, same chart, 0.08, 0.28. 0.28. For this, the graph value is PU by FCK is also 0.08. For this, we are going to find this 0.2, 0.4, 0.6, 0.8. This is 0.8. The PU by FCK value is 0.8. This graph we are assuming. For this value, we are coming this as 0.135. We are putting this value as the same value 0.135. For this 0.135, we are putting this in this formula in, and we are finding this mu value. We are finding this mu value by putting this value in this formula. We are putting this value of FCK, value of B, value of D, and this value is already available. Equating these things, we are coming to this value. On this, we are finding this value as this much. This is Newton mm. This is converted into kilonewton mm. That kilonewton mm we have arrived here. Then existing moment in column number M, column M is 40.4, factored moment XU. This is also same XU. Mu by MUX1 we have already arrived 125. This one is existing moment. 60.6 divided by 125 point something. That value is we have put here. So it means what? For the section and for the reinforcement, we have provided the maximum bending moment which can be taken by the column is 125 something. That value is here. Now we are considering the YY side direction. Similarly, YY direction we have asked, if the XX direction, if the depth is 450 in X direction, the breadth will be 230 in the, by considering this XX direction. If we are coming to YY direction, there the depth becomes width, width becomes depth. See here. That is a change only we are going to do, the same reinforcement, etc. Percentage reinforcement 1.55 as we have already assumed. The reinforcement is this much. .55. P by FCK value is 0.08. We have already arrived. Factored axial load is this much. MU, that is MUY1. This is MUY1. Make it as MUY1. We are assuming this as MUY1. Then D dash by D value is 0.18. How this comes as? The bending direction width is 230 mm minus effective depth cover to reinforce 195. D dash is 35 divided by D value is 195. This value is 0.179. That we have written as 0.18. So using these three values indicated in red from the chart, we are arriving this value. Previously, we arrived chart number 48, which is suitable for d dash by d value is 0.1. Now the d dash by d value is 0.18. For that, we should change the chart. D dash by d value is 0.2. This is the nearest value, so we can use this chart. In this, the P by FCK value is 0.08. 0.08 is this graph. We are going to use this graph. Okay. What is PU by FCKX? Y direction value is this one, 0.28. 28, this is 0.28. So intersection of this point is this one we are arriving. So going to Y x-axis, this value comes as this 0.11. Now the correct, now we have taken this as 0.11 from the chart. Okay. Then from this equation, putting all other values, mu value comes as this one on as Newton mm, converting this into kilonewton mm, as this is the corresponding moment of resistance of the column for the reinforcement of 1.5%. That this is the and may be called as the moment resisting moment in the YY direction. Whereas the existing moment in the column is this one, the factored existing moment is column is this one. Then find this value. This value is actual moment divided by the resisting moment, available moment or resisting moment in the as per the chart is this value. How to find this? This is available value is 5.64 divided by moment of resistance is 52.371. 5.64 divided by 52.371. Okay. This value comes as on calculation, this value comes as 0.17, sorry, 0769. That we have printed it here. Okay. Now after completing these things, then we are going to another chart. The percentage of reinforcement we have provided is this much, 1.55 percentage. Chart number 63 we need to go for the design in biaxial bending. This is chart number 63. Here PUZ. PUZ means the capacity of the column for resisting the vertical load. 1.55 is the reinforcement percentage we have already provided. This is y-axis, this 1 percentage. 1.2, 1.4, 1.6. Okay, this is 1.55. Getting the coordinate, this comes as this one for Fe 500 steel. going to, then character strength of concrete is M20 concrete. For this is the corresponding graph in the section. So taking this into this point, corresponding value is 10, 11, 12, 13, 14, 14 plus 14.5 maybe 14.5. This is 14.5. We have already determined even this. From the chart number 63, we are arriving this as 14.5. For the PUZ, putting this 14.5 as the, and we have already given this AC area of steel is already available. Equating this, the PUZ, we are arriving this as this much Newton. This converting this into kilonewton, this value comes. Then PU by Z means simple thing. PU means existing value, existing load. Factored axial load is 571.32 divided by resistance of the column is 1500.75, 0.380697. That value we have already we have written here. This one we have written here. Okay. We are coming to another slide. This is 0.38 mu by mux1. We have already arrived this one. Here it is here. Using this chart number 64, we are arriving this value as per chart. Though we are having this value separately, as per chart what it says we shall see. This is chart number 64. Mu value is 0.68, Pu by Z value is 0.38, 0.48. .38 is the graph value, x-axis value is 0.48. 0.38. This is the 0.38 approximately. This is 0.3, 0.4, this 0.8. This blue line approximately indicates the graph for 0.38 value for a PU by PUZ. Then y-axis, x-axis value is 0.48. This 0.45, 0.48, maybe somewhere here. Equating this, it meets somewhere here. Y value comes this one is the Y value, which is maybe 0.6, 0.65, 0.68 maybe the value. This is 0.68 we have put here. From the chart value 64, the MUY by MUY1 as per chart is 0.68, whereas the calculated value is only this much. So arrived value is more than the actual value. So the column is perfectly safe. Hence the adopted value of B is 230, depth is 450, percentage rainfall to 1.55%, that is 8 numbers exists in drum dot with a square amount this much is perfectly okay. Okay. This is the design for doing this for biaxial bending. Generally the bending column design for biaxial bending is the little confusing and complicated. See this video once or twice additionally, then you will be having a clear idea to design this. Engineers, please go through this 2 times or 3 times and get it practiced by yourself. The persons who like this, who find it useful, please like it, please share it, please subscribe it. Thank you.